All right, let's consider this circuit. I have a circuit, and I want to know a couple of different things about it. First, what is the equivalent resistance? What is the current through resistor R1? What is the potential across each resistor? All right, so first of all, to find the equivalent resistance, I just add up the three resistors. So that's going to be 1 ohm plus 2 ohms plus 2 ohms, and that'll give me a resistance of 5 ohms. All right. And then what is the current through resistor R1? Well, in order to answer that question, I want to know, let me just redraw this circuit actually, what is the current through the equivalent resistance? So I have a 10-volt battery hooked up to a 5 ohm equivalent resistor. And so if I want to know the current flowing through this circuit, I say V equals IR. So I equals V over R. That is 10 over 5, or 2 amps. All right, so that is my current through the equivalent resistor. But remember our rule, resistors in series have the same current. And it's the same current, in fact, as what's through the equivalent resistor. Okay, so my current then through R1 is going to equal to what I'll call the equivalent current. That's the current that we calculated up here. And that's equal to 2 amps. When I say equivalent current, I mean that is the current through the equivalent resistor. And then if I want to know the potential across each resistor, well, we may recall that resistors in series all have the same current. So I'm just going to calculate IR for each of them because I know their resistance and I know their current. Actually, I'm not going to differentiate here because they all have the same current. Now let's see, I had a 1 ohm, 2 amps, and 1 ohm. For the first one, 2 amps and 2 ohms. For the second one, 2 amps and 2 ohms. For the next one, and then that'll give me the voltage. So I have 2 volts, 4 volts, 4 volts. 2 volts, 4 volts, and 4 volts. Notice here that these three, 2 plus 4 plus 4 equals 10 volts, which is the same as this number. So the voltages, and this was one of our rules, the voltages V1, V2, and V3 of resistors in series all have to add up to equal the total voltage or potential difference of the power supply. Let's see. So likewise, let's see. The change in potential across the resistors in series. As to equal the total potential. So if you know the voltage across each of the first two resistors, as we do, we said that V1 was equal to 2 volts. V2 is equal to 4 volts. So if we just know 2 of them, then we can find the third. We can say 10 volts minus 2 minus 4 equals 4 volts. And then that would give us V3, which would be 4 volts. We did this with capacitors as well. And mathematically, anyway, at least it holds the same. So try this one on your own. You want to find the equivalent resistance by adding these three up. That'll give you an equivalent resistance, and then you can use that to find the current. All right, I is V over R. And then once you find the current, you can find the potential for each of the resistors. Actually, it's only asking for the 8 ohm resistor. So you just multiply that current times that resistance, and you'll get the potential across that 8 ohm resistor.